You make
Okay.
sure that this is off,
Okay.
no signals going.
Okay.
And if you don't see anything changing here,
Hmm.
make sure that it's continuous.
Hmm.
To make sure that it's getting updated all the time.
Okay. Okay.
The next step is basically to check your power supply.
Okay.
So this one here is 15 volts
Okay.
for this one here. The
Okay.
operating volts, yeah, if you can read it here, is 15 volts.
Hmm.
It just needs
Okay.
15 volts.
Okay. Okay.
خلاص. And now it's operating as the driver, which
Okay.
has linear gain only.
Hmm. Okay.
And as you can see here, the next one here,
Hmm.
this is basically 28 volts
Okay.
going here.
Yeah.
This is the drain voltage. And
The
this
drain
2.5
voltage.
volts,
Okay.
it's actually negative 2.5, but يعني, let's say, because the polarity is just came
Okay.
here. It's
Yeah.
basically for the gate
Yeah.
control.
Okay.
Now you turn it on.
Okay.
This should be around 0.8,
Okay.
0.8 amps. The current consumption of this at the constant without anything is
Okay.
0.8 amps.
Okay.
And then you turn this on,
Hmm.
and this should be 0.2,
Hmm.
0.2 amps. You see?
Okay.
And in
Okay.
the gate current, you don't have any gate current.
Okay. Okay. Now this power supply is for which one of these two?
This one here.
It's for this one. Okay. The down one is for this.
So what you have to
Then
take
the
care
one at
of,
the top is the for
this one.
this one. Okay.
You have to take care that this is 0.8
Okay.
and this is 0.2.
Okay.
Because if this is higher, the
Hmm.
amplifier might be burned. So you just
Oh.
have to keep it like this.
Okay. Okay.
And check, and maybe sometimes if someone touches this, make sure that this is 28, make sure that this is 2.4 or 2.5.
Okay. So how do you tune them?
This here, the volting knobs, and this here.
Oh,
Just make
okay.
sure that before turning it on,
Hmm.
make sure that they're correct.
Okay. These values are correct.
Yeah.
Okay.
So now, like, you checked everything,
Hmm.
your amplifiers are on, you
Hmm.
see the light is on.
Okay.
Now maybe like, okay, you can test the signal.
Hmm.
Yeah,
So how do you go about testing the signal?
yeah, this here, SPA is main spectrum analyzer,
Okay.
SA is signal analyzer, SG
Okay.
is signal generator.
Okay.
So I'll press signal generator.
Okay.
Now I can pick like from select pattern, a pattern.
Hmm. Okay.
Yeah, for now I won't tell you how to load the pattern and all of this because this is just a
Okay.
simple demo.
Okay.
Yeah, for example, okay, I have the signal here.
Hmm.
It's an LTE signal.
Hmm.
It's 20 megahertz
Okay.
and it's sampled at 61.44 megahertz. So
Okay.
it's a 20 megahertz signal.
Hmm.
I selected it, okay?
Okay.
And now I can change the amplitude.
Okay.
This is basically the average power of the signal that I want.
Hmm.
So
Hmm.
let's say I'm setting it to minus 30.
Okay.
Yeah, in this you should never go above minus 15, minus 16 dBm or something like this. Yeah.
Okay. Okay.
It's always going to be something less, yeah,
Okay.
unless you're using a different amplifier.
Okay.
But let's say now it's minus 30, right?
Okay.
So now to turn it on, here, modulation.
Hmm.
If I just press signal only the signal, only an unmodulated signal will be sent.
Okay.
So I have to add modulation,
Okay.
and then basically you can see here that this here, the ACLR values do not fit it because these are for 40 megahertz. I just need to
Hmm.
change it, for example, here.
Hmm. Okay.
And for now, I just changed some stuff. Yeah.
Okay.
So now you can see the signal is 20 megahertz.
Okay.
This is the average power
Hmm.
of the signal.
Okay.
So
Okay.
right now it's minus 17, minus 18 dBm, right?
Okay.
And these are your ACLR values. Here, L1 is the ACLR on the left. The first one, the blue one, L1. It's
Okay.
minus 47.8. This is good.
Okay.
And L2,
So this L1 and L2, what are they?
L1 is the SLR here.
Okay, SLR. Okay.
This SLR, the blue one. L2 is the green one here.
Okay.
Left, second channel. Left, first
Okay.
channel. And this here
Okay.
is upper. No, lower,
Lower,
lower.
lower. Okay.
This is the
Upper,
lower.
upper.
And upper 1, upper 2.
Okay.
You can see the SLR is basically what, minus 48,
Hmm.
minus 48.
Hmm.
Essentially, it's good.
Yeah.
We don't have
What's the meaning of SLR?
minus 45.
The meaning of SLR. What
40.
does it mean?
Yeah, like your SLR should be better than minus 45 dBc to have good
Okay.
linearization. So now
Okay.
this we have good because I'm using a very low input power.
Okay.
So now if I change the input power, increase it,
Okay.
because this is dBm, when you increase it, it becomes like this, yeah? Now I'm
Hmm.
increasing it.
Hmm.
As you can see, when I'm increasing it, it's getting
Mm-hmm.
more nonlinear. You
Okay.
see? Look
Okay.
at it.
Yeah. Yeah. Yeah.
It's now minus 45, minus 45.
Hmm.
Barely passing.
Hmm.
If I increase it more, see? Now
Okay.
it's failing. I increase it even more, see?
Hmm.
Increase it even more,
Hmm.
increase it even more.
So this is getting non-linear right
Yeah,
now.
right now it's very nonlinear.
Yeah. Okay. Okay. Hmm. Okay.
See? It's
So
almost minus 30, which is
most
very bad.
minus, which is very bad. Okay. Oh, I see.
And
Okay.
always check the current. You see the current consumption right now? For this,
Uh,
it decreased.
the current consumption
Yeah.
for
This, it
okay.
decreased because now it's operating more efficiently, like this driver here.
Oh, okay.
And this one is also increasing, you see?
Hmm.
Because now, and check the amplifier is hitting up. Touch it. It's hitting up a bit.
Hmm. Yeah, it's getting hot.
Yeah, so, yeah, like when you do this, yeah, don't keep it for like more than like 5 minutes, something like this.
Okay.
But you can see it right now, so.
Oh yeah.
So now this is a nonlinear signal.
Okay. So is it how do we now linearize this amplifier? So
So
how do we
now,
introduce pre-distorter into this system now? What we're trying to do is to introduce a pre-distorter which is having a function that's
yeah.
an inverse to the behavior of the
So now what I need to do is what?
amplifier. Okay.
So let's say you already have your signal.
Yeah.
It's working well.
Okay.
You have to go to the signal analyzer
Okay.
and then capture the signal basically. If I go to
Okay.
frequency, and then trace nodes, frequency. Okay, see here, this is the signal.
Okay.
It's not no, it's not non-linear because the amplitude is very low.
Okay.
Let's say I'm having it like minus 21. I go to signal analyzer,
Hmm.
check everything, and I like it's a very more steps, but anyway, let's say yes, I have a signal.
Okay.
I capture it,
Okay.
capture the signal. After capturing it, I save the captured data. It will be outputted.
Okay.
Execute, execute the exact thing. So just give me a file
Okay.
that has the I and Q, I and
Okay.
Q
I and
points,
Q. Okay.
and then you
Okay.
take the I and Q points,
Okay. We now install. Would you?
and then process it in your software.
Okay. There is a software we have to use for that, right?
Yeah, yeah.
So how do we now connect that to this entire system? The software. I mean
So
the.
like, let's say from the beginning again.
Okay.
Let's say
Now,
I
what's
want
this
to.
one doing? This particular monitor.
It's copying this.
Okay. Okay. We copy the software in this monitor.
No, no, no. This monitor is basically a copy of this. Yeah, just make it in here.
Okay, just for us to see what is going on
Yeah.
there.
So
Okay.
yeah, for
Okay.
example, I have signals. I don't know. Anyway, normally, if you want to add a signal,
Hmm.
you sign into your AOS drive here,
Okay.
and you put the signal there in your PC. And then
Okay.
you open this here.
Hmm.
It's called IQ Producer. This one.
Okay.
You go to general purpose.
Okay.
Go to convert,
Oh.
and here basically you take your file. you get your signal file. It's a text
Okay.
file that has
Okay.
the I and Q.
I and Q. Okay. It has them inside.
Yeah,
Okay.
inside, right? They're just
Yeah.
separated by space,
Yeah.
and you have two columns.
Yeah. Yeah.
You choose it,
Okay.
and then you choose your sampling rate,
Okay.
and then you just convert.
Wow.
Okay. So
Okay.
now
I
after you
see.
convert, you go to signal generator.
Hmm.
You go to load pattern to load
Okay.
the pattern that you just converted.
Okay.
Converter IQ producer, because this is what we
Hmm.
used, right?
Okay.
And then here you'll find your pattern
Hmm.
loaded here.
Okay.
Now, for example, these are all patterns that I used.
Okay.
You'll find yours loaded here.
Hmm.
And then you just
So.
choose it, you press load,
Hmm.
and then select pattern,
Hmm.
convert IQ producer, you'll find it
Okay.
here.
Wow. Okay.
And then you just basically do the same procedure, yeah. You go
Okay.
signal generator, you choose
Okay.
your you choose the amplitude, and
Hmm.
then you start,
Hmm.
and then you see the spectrum here.
Okay.
You see it's off, so you can't do anything now. But anyway,
Okay.
like you see the spectrum here,
Okay.
you go to trace, and for example, I want to see in trace A.
Hmm.
So I go to trace,
Okay.
active trace is A, I'm
Okay.
going to make it right. Right is basically
Okay.
now it's writing.
Oh.
If
Okay.
it's view,
Okay.
and you'll just take a screen capture of the
Okay.
of the signal. And then you could do the same in B. You can
Okay.
make it right or make it
Hmm.
view. This way you could compare different signals at the same time.
Oh. Okay.
And this basically just to show you the SLR reading. And then
Okay.
and you check your frequency. If you have the
Mm-hmm.
correct frequency,
Hmm.
the spectral analyzer, you also
Hmm.
have the correct frequency.
Okay.
And then in for example your signal itself,
Hmm.
ACP is the ACLR measurement.
Okay.
If you press on it, in band setup,
Hmm.
you choose your center frequency. My center frequency is
Mm-hmm.
2.593,
Okay.
like
Okay.
yours, 2.593.
Okay.
This
Okay.
is my center frequency.
Hmm.
My carrier bandwidth is the bandwidth that I'm interested in, which
Yeah.
is
Okay.
20 megahertz.
Okay.
This is the in-band setup, and then
Hmm.
offset setup.
Hmm.
I choose the channel bandwidth for the SLR measurements here. It
Mm-hmm.
should also be 20, right?
Okay.
20, 20, 20.
Okay.
And then the first offset is 20 megahertz. And I want to have an offset of 20 here and 20
Hmm.
here.
Okay.
Second offset, 40 megahertz. I want to have here 20, 20,
Okay.
20, 20, which is 40,
Okay.
to measure the second SLR
Okay.
and the first SLR here.
Mm-hmm.
And then you could press copy
Hmm.
to give you a screenshot.
Oh. Okay.
And
So you can have these screenshots, and one can
yeah,
even
and the screenshot will come in
Okay.
copy files here.
Okay.
And if I sorted by date, see here's
Wow.
the screenshot.
Wow. Yes, one can
And
even
then
use this on publication, right?
yeah, and then you go
Okay.
to signal analyzer,
Okay.
press step, check frequency.
Hmm.
It should be 2.593 center,
Okay.
and the span should be enough. Yeah. For example, this is 20 megahertz. I want to
Hmm.
capture four, 4 to 6 times the bandwidth,
Hmm.
and six
Okay.
times is 120, which is and this is 125 is good enough
Okay.
because I want to capture the nonlinearities in the
Hmm.
first and second case. I
Okay.
want to capture the signal, all of this.
Okay.
I don't want to just capture the signal. Yeah,
Okay.
I want to capture all of this.
Okay.
That's why and here the span is relatively high
Hmm. I see.
compared to the signal itself.
Okay.
And then check trigger.
Hmm.
Make sure the trigger source is signal marker.
Okay.
The signal generated marker is basically just a,
Hmm.
a signal that goes high
Hmm.
at the beginning of transmission. Yeah.
Hmm.
When the signal starts going,
Hmm.
there's an internal bit that goes up,
Hmm.
and basically it tells the signal analyzer to
Hmm.
start capturing.
Okay.
And then you just press signal. You see now it's called trigger wait because the signal generator is not working.
Hmm.
If it was working and I pressed single,
Hmm.
it will capture
To
and it
capture
will view it
it.
here.
Okay.
So after it views it, I go to capture. The capture time is basically the time length of your signal,
Okay.
and normally it will be only 1 millisecond. Yeah,
Hmm.
for you probably. If it's going to be a
Okay.
1 millisecond signal, you have
Hmm.
to have this the same 1 millisecond. And then
Okay.
you go to save capture.
Hmm.
You choose a file name.
Hmm.
You choose an output sampling rate, which
Okay.
which should match your input sampling rate,
Hmm.
because then when
Okay.
you do the DPD, they have to have the same sampling rate.
Okay.
And then you press execute digitization to save it.
Hmm. Okay.
And then it will show up here in
Settings.
Signal Analyzer.
Okay.
It will show up here as two files.
Hmm.
And then you take these two files, and then you can create a text file that contains the output INQ. And
Okay.
then with your input IQ,
Okay.
you do
Hmm.
some alignment in the software, and then basically you just
Hmm.
do your DPD.
Okay.
That's it.
Hmm.
You want to try turning it on?
Okay. Okay, I should come and try it now. Okay.
You
I
want to
should
try?
come and try it.
You want to try?
Okay. I'll try it now. At least you are here. You assist me if if I make any
Yeah.
error. Okay. Let me continue doing this recording.
Oh, do you want to record it?
Yeah. I want to record everything. So the first thing we'll do is check this to make sure this one is on. I think this has gone off.
Yeah.
It's
There.
meant to be 2.2, right?
No. Check. First of all, you don't see the yellow light here, so it's off.
Okay, it's off. Okay,
So
so
these
it's
are the
on.
maximum allowable currents.
Okay. Okay.
So now you see that, okay. You see the voltage here, it's
Okay.
15 volts, and here it's
Okay.
28, and here 2.5. So it's okay.
Mm-hmm.
So now you can turn it on.
Okay. So I can turn this one on.
And check the current now
So the current now is 0.2 amps
at 28
and
volts,
20
which is correct.
volts, which is correct.
And the
Okay.
upper one,
And the upper one, if you turn it on,
zero point 0.8 and 15.
0.8 amp. Is this ampere?
Yeah.
Okay. And this ampere is for which one?
No, this is not connected.
Okay, this one is not. Okay, there are two sides
Yeah.
of the amplifier. Okay. This one is 15 volts. Okay. So
So it's okay.
so this one is okay right now.
So now you go to signal generator,
So the signal generator.
SG.
Signal generator SG. So we turn it on. Then
You select pattern.
we select pattern. Is there anything like select pattern here? Okay, select pattern. Okay, so
So
this is
now,
where
for
we now.
example, select the 40
Mm,
NRC. Select.
this one.
Yeah.
Okay.
40 is basically just tells me that this is a 40 megahertz signal.
Oh, 40 megahertz signal.
Yeah.
Okay, this 40 NRIC. Okay, it's 40 megahertz
40
signal.
megahertz signal sampled at 153.6 megahertz.
Oh, okay.
So now we select it.
So we select it.
Now this is the signal that you'll be using. Okay.
Okay.
Close.
So we'll close first. Okay.
And now.
This is a signal, right?
So
This
now
is now.
now press spectrum analyzer. You don't want to see this.
Spectrum analyzer.
SPA.
SPA. Why is it there? SPA. Okay.
Well, this is your spectrum analyzer.
Okay.
Now turn it on.
So it's on right now.
No, first of all, check the signal generator. Check the signal generator. Check what is the amplitude.
Okay, signal generator SG.
What is the amplitude?
Amplitude of the signal generator. Where is it there?
The amplitude
21
here.
is 21. Yeah.
Negative 21.
Yeah, negative 21. So
So negative 21 is good. Yeah.
It's good, right?
Yeah.
Okay.
So now
And
turn it on.
So we turn the
Signal generator on.
signal generator on. So go to signal generator.
The buttons here. The two buttons here.
Right.
Turn
These
it
two
on.
buttons.
Yeah.
Okay. Oh, okay.
Now you see it's very big, right?
Hmm.
It's not enough.
I can see.
So press SPA again.
SPA.
Spectrum analyzer.
Spectrum analyzer.
So now what do you want to do? You want to have a bigger view of the spectrum, right?
Okay. Yeah.
So first of all, press span. Span here. controls the span here.
Where is it?
In the buttons here, span.
Span. Okay, okay. Span. Okay.
You see the span is 100 megahertz.
Oh, 100
So turn the
megahertz.
knob, make it bigger.
Oh, okay.
No, in the opposite direction. Make it 250.
250. Okay.
And now press continuous.
Continuous.
Press it
Okay.
continuous here. You just refresh.
This one?
Yeah.
Okay.
See, it refreshed the signal.
Oh, I see.
So now you see the signal, صح?
Yeah.
Now, what is the next issue? The next issue is the
Okay.
SCLR is wrong.
Mm.
So press measure,
Major. Okay.
ACP,
ACP. Okay.
in band setup.
In band setup. Okay.
The first thing is here, the carrier bandwidth.
Carrier bandwidth.
We change it into what?
250 MB, right?
Here, what is the new carrier that we chose?
Okay.
What did we choose? 40.
Which one are you talking about?
The bandwidth, so the bandwidth here. We
Okay,
chose the
this
new one,
band.
40.
Okay, 40.
Yeah, so make this 40 instead of 20. 40 megahertz.
Okay, this one is carrier bandwidth.
Yeah.
So how do we go about changing it?
Type it in.
Okay. I'll
Type.
click on it first.
Yeah, click on it and type 40.
40. Okay, first of all.
40. And the megahertz here.
Oh, okay.
So now you see,
Okay.
it is telling me here 40. But this is still wrong, right?
Okay.
So you go up.
Up.
Here, this here, it goes back.
Okay.
And then offset setup.
Offset setup. Okay.
And here also the same. The channel bandwidth is 40, not 20.
Oh, it's
So
supposed to be 40. So
yeah,
we
so you
click
change
on
it.
40 again, right?
Press it. 40
40
megahertz.
megahertz. Okay.
And now you
Okay.
go to the second window. Press here.
This one?
Yeah. The first offset.
First offsets.
On. Press it again.
On.
Change it.
Okay.
Change it here.
Change.
Press here.
This one?
Yeah.
Okay.
Also.
Okay, that should also be 40.
Yeah.
Okay. 40. Okay.
Enter.
Megahertz, right?
Yeah. And the second offset.
The second offset. This one?
Oh, press it. Turn
This
it on.
one?
Turn it on.
This one. Okay.
It should be double. Turn it on. Turn it on.
Okay, this one? Okay.
And also should be double. Because right now they're the same.
Okay.
This is 40.
Okay.
This is 40 offset.
Okay.
And this should be 80 offset.
Okay. So now, this offset one is this one, right? This L2.
This blue, the blue one.
The blue one.
And offset 2 is the green one. But they're at the same position. So they're
okay, that's why we cannot see. So what do we now do? We double this one, right?
yeah.
We make this one 80, right?
Turn it on. Down.
Okay. This is what we change it to 80.
80, yeah.
Okay.
Megahertz.
Okay. So we can see it from behind. Okay.
Now, خلاص, you go back here.
Okay. SP here.
Active trace. Here, B. Okay, so now.
Trace.
Yeah. So, but now, let's see. We have, I said the trace, active trace is A. I said the mode right.
Okay.
But now, look here. This is here.
Okay.
This is the average power here.
Oh, okay.
It's minus 9.6 dBm.
Oh,
this is the average power that's going here at this frequency here.
Okay.
And look at your SLR.
Okay.
Minus 32, very bad.
5, okay.
Very bad. Minus 32, very bad.
Okay.
Very normal here.
The one that is okay is like 45, right?
Yeah, higher than 45.
Okay.
So you see, very bad, and this is acceptable. But the main issue is this one here.
Yeah, this guy.
So now
we need to linearize this guy.
First of all, touch here. It's getting hot.
Oh, it's getting hot.
Yeah, and later on, when you're using it for a lot, you see the fan here. You just take the fan and turn it on.
Oh,
and
can find it.
let it
Oh,
cool
okay.
the device.
Okay.
There's another one here.
Okay.
You take it
Mm,
and cool the device with it.
I see. Can we turn it on it so that I can cool it off? What do you think?
Connect it to the USB here.
Okay. Yes.
There.